Good afternoon. Today we are going to work on adding radicals. So when we deal with radicals, before we start adding them or subtracting them, we have to keep in mind that there are three different types. Let's see if this works. Nope. Let's use this. Three types of radicals. First one is something like 64. Square root of 64 is 8. This is a perfect square. I don't know how to spell perfect. Perfect square. And perfect squares, remember, square root of 64 can be written as the square root of 8 times 8, which can be written as the square root of 8 squared. Now that radical will cancel with that exponent, leaving us with 8. Hence why the square root of 64 equals 8. Our objective is to get rid of that square root. The only thing that gets rid of a square root is a square. So if we could write a number as a square, that will cancel with the radical outside of it. So square root of 64 equals 8. We notice the 64 is in the radical. The 8 is outside because the radical has been eliminated. The next example is something like the square root of 20. Now this is not a perfect square. However, it can be simplified. So we're looking at factors. Let's erase this. We're looking for factors of 20. So we could write the square root of 1 times 20, or the square root of 2 times 10, or the square root of 4 times 5. Those are the factor pairs when multiplied produce 20. And we know that we can separate each one of those. If they're being multiplied, we can write each one as a radical under its own house. And we're looking for a perfect square. So we have two sets of factor pairs that have perfect squares. That's how we're able to simplify this. We can't simplify it straight up because it's not a perfect square. It can't be written as a number times itself. But we can look for factor pairs that may have a perfect square in it. Now, the square root of 1 is an interesting one because if we simplify that, that equals 1 times the square root of 20, which equals the square root of 20. Now, did that get us anywhere? No, because we're still at a square root of 20. So we would not choose 1 as our factor pair because it doesn't get rid of our number. It doesn't get it smaller. It doesn't simplify in any manner. Now, 2 and 10, why would we not choose these two? Well, because square root of 2 or square root of 10, neither are perfect squares. So I wouldn't be able to simplify this. I wouldn't be able to simplify this. We would, however, choose the square root of 4 times the square root of 5. The reason why, because the square root of 4 is a perfect square. So we can simplify that. The square root of 4 we would write as 2. And then we'd bring down the square root of 5. So the square root of 20 can be simplified to 2 times the square root of 5. And then the last one that we have, the last example, is the square root of 14. If we look at the square root of 14, it has no factor pairs that are perfect squares. So if we look at the factor pairs of 14, we have 1 times 14 or 2 times 7. So if we break those up in their own houses, we notice that not a perfect square, not a perfect square, not a perfect square. Now, yes, that's a perfect square, but remember, in that example, we're still left with square root of 14. So we haven't gotten rid of anything. So the only other factor pair is 2 and 7, and neither are perfect squares. So that wouldn't be able to simplify. So we would just leave it as the square root of 14. That cannot be simplified. So the three examples are a perfect square, a number that is not a perfect square but can be simplified, or a number that is not a perfect square and cannot be simplified. So we're constantly looking at that prior to doing anything. So if we look at example number 1, one of the things that we like is that we want to, it says add these two. When can we combine radicals? When can we add or subtract radicals? Well, when they have the same radicand, when they have the same square root. So because this is square root of 5 and this is square root of 5, because they have the same radical, we are able to combine their coefficients. So we have -3 rad 5 plus +2 rad 5. So we're going to combine those coefficients. -3 and +2 makes -1. And then we're going to keep the radical. So here's the first interesting thing. We're not going to write -1 rad 5. We would write negative rad 5 because we don't write -1. In high school, they're going to accept this. They're not going to want to see the -1. They're just going to want to see the negative sign. So that's a little bit tricky. Let's look at the second one. We like this because we have like radicals, and that means we're going to combine their coefficients. We have -3 rad 2 and -3 rad 2, which makes -6 rad 2. Combine their coefficients, keep the radical. We have like radicals, rad 3, coefficients are -2 and -1. That's a nice little tricky one. We talked about that negative. We're not going to see the 1. Here's a great example of not seeing that 1, but we know that we're going to combine their coefficients of -2 and -1, which makes -3 rad 3. That radicand stays the same. It's sort of like when we see 2x plus 3x. We're going to combine their coefficients, which produces 5x. It doesn't produce 5x squared. It produces 5x. Same exact situation here. You have like terms because they have the same radical, so we're going to combine the coefficients of those radicals. We combine the coefficients of those variables. So 2 rad 5 plus 2 rad 5 is 4 rad 5. A lot of students will make a mistake here. They will write 2 rad 5. We will not take the square root of 4 because there's no radical. It's not in a rad. That's outside. 4 is outside of the radical, so we would not need to take the square root. Most students are going to make a mistake. They're going to make it right here, and they're going to write the wrong answer of 2 rad 5. It is not 2 rad 5. We are adding their coefficients. 2 plus 2 is 4. We don't take the square root of 4 because it's not under a radical. We have, again, we check, are they like terms? Yes, they both have the same radical, rad 5, so we're going to combine their coefficients, -2 and -2, which makes -4 rad 5. And we're done. Ooh, now we have 3 terms. We have 2 rad 3, +3 rad 3, and negative rad 5. So our only like terms are the ones that have the same radical. So rad 3 and rad 3. So we're only going to combine the coefficients of those 2 terms. So we'll combine the 2 and the 3. And when we combine them, that will be 5 rad 3 minus rad 5. These are unlike terms because they have different radicals. That's radical 3 and that's radical 5. So those are not like terms, so we cannot combine those coefficients. So we have to be, we can just leave it like this. This is simplified. We're looking at each radical. Each time, we've done 6 problems. Each time we're also looking to see, whoa, that was kind of crazy. We're looking to see, can we simplify those radicals. Nope, those are already simplified. We can't, remember there are three types of radicals. It's not a perfect square. It's not a radical that can be simplified. So that is simplified, and those are unlike, so we can't combine them. We have 2 rad 3 minus rad 2 minus 2 rad 2. So we're looking for like terms. These are the two like terms because they have common radicals. So that first term, 2 rad 3, cannot change. We're going to look at the coefficients, -1 and -2, and that makes -3 rad 2. Oh, that's an interesting one. These are not like terms. This is rad 3, this is rad 2. We can't combine their coefficients. So this is going to be my answer. There is no standard form with this, so if you wrote -3 rad 2 plus 2 rad 3, okay. Probably not the most logical. You'd probably write 2 rad 3 because it came first in the starting problem. All right, we have like terms, -2 rad 3 minus rad 3 plus 3 rad 6. So we're going to combine these like terms. -2 rad 3 and negative rad 3 makes -3 rad 3 plus 3 rad 6. Rad 6 can't be simplified. There's no factor pairs of 6 that have a perfect square in it. Remember our perfect squares that we're looking for. There are 9 perfect squares that help us between 1 and 100. It's rad 4, rad 9, rad 16, rad 25, rad 36, rad 48, excuse me, 49, rad 64, rad 81, and rad 100. Those are 9 perfect squares that we look to see if they're factors of that radical. That's how we're going to reduce radicals. So these, they're not the only ones. You can do 121, you can do 144, 169, 196, etc. We can keep going, but these are the most common ones that we're going to test to see if they are factor pairs. Factors. All right, so that's my answer. -3 rad 3 plus 3 rad 6. That's simplified. Okay, we have these are like terms. So we look at their coefficients, 3 and 2, which makes 5 rad 2 minus 2 rad 6. That's my answer. I'm looking for like terms. -3 rad 6 and +3 rad 6, they're going to cancel and make 0. So that's left with -2 rad 5 is my answer. All right, now we see that these are unlike. However, we need to make sure that these radicals are simplified. So rad 6 can't be simplified, but rad 24 can. So I need to simplify this radical. This needs to be simplified. Must be simplified. So how can I simplify -2 rad 24? -2 rad 24. So I'm looking at that list of factors. 4, 9, 16, 25. Well, not 25 because that's bigger than my radical. So do any of these, can I find are any of these a factor pair of 24? Yes. 4 is. So I can break rad 24 into rad 4, rad 6. Why did I choose 4 and 6? Because 4 times rad 6 gives me rad 24. Why didn't I pick 3 and 8? Because neither of these are a perfect square. Neither are perfect squares. So it doesn't benefit me. It doesn't help me by picking a non-perfect square. I picked these two because 4 is a perfect square. And I'm going to bring down the 3 rad 6 over here. That just comes down along for the ride until I see, okay, So negative 2 times, there's always multiplication between those two, negative 2 times rad 4 times rad 6. Rad 4 is a perfect square. Square root of 4 is 2 times rad 6. Now these are outside the house, outside the radical, so I can combine them. I'll simplify that. I'm bringing down 3 rad 6. Negative 2 times 2 is negative 4 rad 6. That 4 is outside. I'm not going to take the square root. And look, I have like terms. Like terms. It didn't look like they were going to be like terms, not when they started. But after I simplified, I have like terms. So I'm going to combine their coefficients. The coefficient is 3 and negative 4. 3 and negative 4 makes negative 1. So I have negative, well, let's do this, negative 1 rad 6. And then I'm going to write it as negative rad 6. Only answer. You cannot write it as negative 1 times rad 6. You have to write it as negative rad 6. We'll see if that comes into play for the assessment. All right, negative 2 rad 3 cannot be simplified, but rad 27, so I'm looking through for 9. 9 goes into that. Rad 9 times rad 3 makes rad 27, and this is a perfect square. That's why I chose that one. So negative 2 rad 3 plus 3 times rad 3. These are outside together, so I'm going to simplify them. I get 9 rad 3. And now I have like terms, so I'm going to combine their coefficients. And negative 2 and 9 makes 7 rad 3. Number 13, ooh, I got 2 of them. All right, so I have the negative out there. 54, I'm going to break into 9 and 6. That makes negative 3 rad 6. Plus 3, 24, I'm going to break into 4 and rad 6. That becomes 3 times 2 times rad 6. So I have negative 3 rad 6. These I'm going to make 6 rad 6. And now I have like terms. I'm going to combine their coefficients. So I get 3 rad 6 as my answer. Circle, good, I already circled that. Number 14, negative 2, 12. 4 is a factor of 12. 4 times 3. And 27, I'm going to break into 9 and 3 again. So negative 2 times the 2 times 3, which makes negative 4 rad 3. And I have 3 times rad 3, which makes 9 rad 3. And I have like terms because they have the same radical. So I'm going to combine their coefficients. That gives me 5 rad 3. All right, negative 2 rad 2 cannot be simplified. The rad 8 can be written as rad 4 rad 2. So negative 2 rad 2 plus 2 times rad 2. These are the same outside, or these are outside of the radical, timesing each other. So that gives me 4 rad 2. I have like terms, both rad 2's, so we combine their coefficients. And I get 2 rad 2 as my answer. Number 16, 18 is going to be broken into rad 9, rad 2. That becomes 2 times 3 times rad 2, or 6 rad 2. Negative 2 times 8 is negative 2 times rad 4 times rad 2, which is negative 2 times rad 2, or negative 4 times rad 2. And then I have negative 3 rad 2. We'll bring that down. That's already simplified. So we again have 3 terms with like terms, which is nice. And let's take each of the coefficients. 6 minus 4 minus 3 gives me negative 1 rad 2. And remember, we can't write a negative 1 as a coefficient, so we just write the negative sign that represents the 1. Negative 2 times 9 rad 2, which is negative 2 times 3 rad 2, which is negative 6 rad 2, minus 2 rad 8 is going to be rad 4 rad 2, which gives me negative 4 rad 2, and then we have negative 3 rad 2. So negative 6, negative 4, negative 3 makes negative 13 rad 2. That's my answer. Negative rad 3 can't be simplified. Negative 3 rad 3 can't be simplified. And we have 3 rad 45. Rad 45, I like 9. So negative rad 3 minus 3 rad 3 plus 3 times rad 5. So negative rad 3 minus 3 rad 3 plus 9 rad 5. All right, we have like radicals. So we're going to combine the coefficients. Negative 1 and negative 3 makes negative 4 rad 3 plus 9 rad 5. These are unlike because they don't have the same radicals, so we cannot simplify or combine their coefficients. 19, we again have negative rad 3. 20, that's a new one. Rad 4, rad 5. So that's negative 3, or negative rad 3, 2 times rad 5. Negative rad 3 plus 4 rad 5. And now we have negative 3 times rad 27. That's going to be rad 9 times rad 3. Negative 3 times 3 rad 3. Negative 9 rad 3. Like terms are on the outside, rad 3 and rad 3. Let's combine their coefficients. Negative 1 and negative 9 makes negative 10 rad 3 plus 4 rad 5. Doesn't have a partner because these are unlike. And last but not least, 3 rad 27 is rad 9 rad 3. 3 times rad 3, which is 9 rad 3. Negative 3 times rad 45. Rad 45 is rad 9 rad 5 times 3 rad 5, which makes negative 9 rad 5. And 2 times rad 45 plus 2 rad 45. Ooh, we could have combined those, but this isn't bad either. Rad 9 rad 5. We would have gotten to this part. Times 3 rad 5 gives me 6 rad 5. So we have like terms because they have the same radical. So we will combine their coefficients. And that's 9 rad 3. Negative 9 plus 6 is negative 3 rad 5. Can't combine the other two because those are different radicals. There's your answer key. Don't worry about the order. The order doesn't matter. Let's look at number 20. So if you wrote negative 3 rad 5 plus 9 rad 3, that's fine. So also here, we're not taking the square root of 9. Don't make that 3. That's outside. The only time we take the square root of something is when it's under a radical. Hope that helps. Come and see me if you have questions.